Hello there, we're going to talk about the offset setting limit for optics tool. The set offset value to cover the shift result of measure is very often action. It's due to that the optic tool manufacturer know about the capability of the equipment limit. So the manufacturer design the offset value to let engineer to edit the offset value as a compensation. Compensation for what? It of calibration calculus. Every time the optic tool do the auto self-test or auto calibration, the calculus will cause a little shift for the tool. So the little shift will cause the result of the measuring also shift. But the shift is a little bit very small. The shift small value is not affect the result of the measuring for the old school type process. For the modern school type process, accuracy is very high, so a little bit shift value will affect the SPC control, even affect the process control. So the manufacturer know their machine will cost a little bit shift after calibration. They design the offset value to let engineer to edit as a compensation. For example, the TK this measuring result is 1000 angstrom. But after calibration, you measure the same product again, it drop to 997 angstrom. 997 angstrom. A little bit shift, just shift 3 angstrom, but it shift really. So after calibration, the value will shift by the calculus of the equipment. So it designed to let engineer to edit the offset value to 3 angstrom. So the 997 add 3 to achieve 1000 angstrom as usual. This is its meaning. So the offset setting has its limit. Limit according to manufacturer's design. You cannot edit the offset setting. For example, you measure the 1000 angstrom thickness, but you set 1000 angstrom offset to be 2000 angstrom. It's too over. So the limit, according to the manufacturer design, it will design the limit to let you set. So the offset value, engineer can set the offset value setting is a very small value. But some equipment has the bypass setting to bypass the limit. So engineers do not bypass the limit setting by adding the parameter of the hardware. Don't bypass the limit. It will cause you don't know the real major result is what. So a good engineer, equipment engineer has to record the offset setting continuously. It means that every time you set the offset setting, you record it continuously every day. To let you know about the offset setting is normal or not. As my appearance, this is the offset setting normal condition. This line is the baseline of the offset value. For example, this time you set an offset value here. Next time you set here. Next time you set here. And next time you set here, set here, set here, set here. You can see that the long-term curve is just around the offset setting baseline. This is a normal condition. Abnormal condition is just like this. This is the baseline offset setting, and you edit offset setting here, here, here. Then you will find that the long term to watch this offset setting, you can see that it's going to shift. Offset setting is going to come higher and higher for long term. It's going to shift. The shift wrinkles, you got to find out the wrinkles. You cannot set the offset setting continuously and ignore the wrinkles of the equipment. Probably have something wrong with it. So this is abnormal offset setting record curve, just like this. This is the normal. And general speaking, like this offset setting value is to cover the capability of the equipment. So the advanced process for the semiconductor industry, you must spend a lot of money to buy the most advanced optics major tool to avoid the poor capability of the equipment. To avoid this case for setting the offset value all the time. Okay, that's all. See you next time.